Okay, today after school we did this limit as x approaches -4 of that function. Again, to evaluate limits you just plug in the x value, but when you plug in the x value you get 0 over 0. 0 over 0 does not mean that the limit does not exist. In fact, the 0 over 0 means that the limit is going to exist. It just means you have a hole in the graph. So you have to figure out what that hole is, or where the hole is, and so to do that we're going to mess with the fraction. As long as you're messing with how it looks and not messing up the actual value of the function, you're good to go. So the first thing you're going to do is get a common denominator for my numerator. I am still going to have the limit, so we still want to write limit x is approaching -4, but I'm going to change the fraction. I'm going to get a common denominator for my numerator, which would be 4x. So if I multiply the first fraction by 4, I'll have 4 over 4x, and the other one I would multiply by x, and so I would have x over 4x. So if I put it together I get that, and then my denominator is going to still be x plus 4. So I've got that limit. Next, still have that limit, limit as x approaches 4, but from what we had before, we have a fraction and a fraction, so what we're going to do is we're going to combine those fractions. Doing the algebra, I'm going to skip over those algebra steps. If we combine those fractions, we're going to get 4 plus x over the two denominators together. So 4 plus x will be in my numerator. My denominators are going to be combined together. We'll have 4x and then 4 plus x, or x plus 4. I'm just going to rewrite the order because the order doesn't matter. That allows us to then cross out those 4 plus x's. So I end up with the limit as x approaches 4 of 1 over 4x, and now I can actually plug in the limit. I don't need the word limit there anymore. I needed it all the way through because I wasn't taking the limit yet. When I plug in 4, I get 1/16. That is the limit of my original function as x approaches 4.